Okay, let's talk about normal distribution. I'm getting out the fun pen. Okay, so we have discussed standard deviation, and standard deviation is the measure of each piece of data, the measure how far away from the average of the data that it is. So normal distribution says that if you have a classroom, so say in our class right now we have about 17 kids, and it would be work in a classroom of 17 too, but let's say we are at university and, oh goodness, I remember in my first year English 110, there was probably 150 kids. So let's say we write a test in a classroom of 150. Not a classroom, it's called a lecture theater. We write a test and we get all those 150 test results back, and we figure out how much different each test score is from the average of the test scores. Normal distribution says that if we did that and if we drew a graph of that, the graph would be, so let's say here right in the middle is the average. Okay, I need to grab a regular pen. Let's say this is the average right in the middle. So that makes sense. We would find the mean of the whole class and our average test score is here. It would say that most people in the classroom or in the lecture theater got close to the average. So there would be a lot of students that got average. Let's say this side of the graph is the number of students. Okay? So lots of people, a high number, would have got near the average. And when you get away from the average, so let's go even to 100, this is 100% over here. So as we get closer to 100%, fewer and fewer people will have got 100%. That makes sense. And the same thing goes the other way. There's going to be the odd few in the class that get a really, really low mark. So the number of people close to the average is high. And as you get away from the average, the number of people gets much smaller. This is called a normal distribution curve. Sometimes we call it a bell curve, right? It makes sense because it does look like a bell. And this is just a fact of life. So any kind of data, it doesn't have to be a classroom setting. If we're talking about, the reproduction of flea beetles or something, and we're talking about the amount born on a day, if we would figure those numbers out, we would find the difference from that average day. And if we would graph it, it would be the same bell curve. This happens in real life everywhere, so that most things happen close to the average, right? And then there's always going to be a few, and it gets less, that are way below average, and there's always going to be a few, and it gets less, that are way above average. Okay, let's talk about the normal distribution curve. A set of data that is normally distributed has a symmetric bell shape when graphed as a frequency polygon. Generally, measurements of living things, mass, height, lifespan, etc., have this type of distribution. The properties of a normal distribution are, so the mean, the median, and the mode are close to equal. So this type of data, if we would find the average, it would be right there in the middle. If we would find the median, the exact center of the data, it would be very close to the mean. And if we would find the mode, the number that occurs the most often, it would be very close to the mean. Second bullet point, the amounts of data within 1, 2, and 3 standard deviations of the mean are shown in the graph. So you can see this graph over here, and the bell curve is easy to see. Here it is, and you can see then that the average is exactly in the middle. Here's another way, another symbol called mu that we use for average. Sometimes we also use x bar, right? That's what we've talked about in this unit. So those two things mean the same. Now, it's a fact here that one standard deviation away, so this far away, oh, I meant to grab pink. This far away here is called one standard deviation. Excuse me. Always, 64% of the data is going to lie in this spot. Most, if we're talking test scores, most scores are going to be this far away from the average. So exactly 68%, 34 on one side of the average and 34 on the other side. So most people will get in that range. There's always going to be a little fewer who are this far. We say this is 2 standard deviations away from the average or from the very center. 13.5% of the data will lie in this range. So it's a little further away from the average. And above 2, 13.5% is always going to fall in this area, which is 2 standard deviations away from the very center, or from average. And then even further, we've got most people who fail badly, not fail necessarily, but are quite a distance away from the middle, the average, 2.35. And likewise, there's always going to be a small percentage that are near 100. This small, the yellow part I've colored in, that's going to be 3 standard deviations away, and also on the lower side. And then the tiny, tiny little bit, I gotta pick a new color here. This tiny little bit, the percentage isn't even written on here. What is it, 0.18 or something like that? I think if we added up all this up, of course percents have to add to 100, we could figure out how much is in that brownish purple range. There's always the tiny, tiny few that are quite a bit above average or quite a bit below average. So it's a pretty crazy idea. In university, professors will often talk about putting their students on the bell curve. It's meaning that when they have a test, they have to fit this curve. So if they have way too many people getting way high marks or way low marks, they're going to bump your mark a little bit up, so they have for sure 68% in that top of the bell. Sometimes that helps your mark when they bump you up so that they have enough people in each section of this bell curve. Sometimes it bumps you downward, although in university oftentimes they don't return your test, so you never really know. But it is common fact that lots of teachers like to have their students fit exactly into this bell curve. Let's look at these other 2 bullets then. Oh, sorry, the last bullet. The area under the curve can be considered as equal to 1, right? It represents 100% of the data. So we know that 100% of all the data needs to fit into one of these areas under the bell curve. So here's an example. I'm going to pause here. I'm going to get out an online calculator and we're going to type this data in. All right, so this is the same online calculator that we used just in the review. You can see here that I took the data from here that we were just looking at, and I entered all these numbers separated by commas here into this online calculator. Then I press Submit Data. And you can see here then that it gave me an average of 72.09375, the mean. It tells me that 32 people were sampled, and it tells me the standard deviation. Now, remember standard deviation? That was the whole formula that you learned in 5.3. Remember, let me walk you through it. We calculated the difference between each data piece and the average, and then with that difference we squared it, and then we added that all up for every data piece, and then we divided by the number of data pieces, in this case 32, and then we took the square root. and that's the standard deviation, the measure of how spread out the data is. Okay, let me record these numbers and get back to our lesson page. So average 72.1, let's say, and the standard deviation it calculated 7.4. Now that was a ton easier using that calculator than using paper and our calculator, although we could do it. Okay, does this data approximate a normal curve? Let's check it out here. Sketch a graph to help you explain. Okay, so let's just do this really quickly. We've got our graph here, and the center here is at 72.1. So if I would do 10, 20, okay, there we go. So the average of our data is 72.1. That's going to be the very center of our bell curve, right there. Excuse me. And now it says, if we go back and look at this bell curve here, so our average is the very center, and then one standard deviation away is our first quadrant. So let's see here, and our standard deviation is 7.4. So 72.1 plus 7.4 will be 79.5 right here. And I guess we could write that down. This is 7.4 over. And now 7.4 the other way, that's 64.7. That's 7.4 that direction. So it's saying now that here is our next piece of data, and there's going to be exactly 34% of the people or of our data within that range. Okay, then one more standard deviation, so 79.5 plus 7.4. Okay, so here's another standard deviation. This, when I added that up, it was 86.9 here too. And if we would go one more, another 7.4 away, and another 7.4 away from the average, we would get. Okay, now let's go back and look at these percentages. So 34% in the first standard deviation away from the center, the average, and then 13.5%, and then 2.35%. Okay, 13.5 here percent, and 13.5%. Right, I went and forgot 2 point something percent. And I think this is B1, 1%. So, if our bell curve should go like this, generally. Yeah. So, that means if we would take this data, so 65 is the first number, 65 would fall in this spot. I just put it anywhere in there. And then 85, and then 72, 85 would fall in here, 72 would. Okay, so let's look at it now. I went ahead and I put all the pieces of data in the right quadrant here. So you can see, and I put the numbers here, there's 5 in that group, 12, 9, 5, and 1. So this data is not quite normally distributed. If I would draw a proper bell curve according to this data, I would draw the bell starting at 1 here, and then at 5, and then at 9, and then at 12, and then back to 5, and then to 0. So not quite a bell, this data, but you can see that exactly these black percentages should be in each standard deviation to make a true bell curve. So you need to look at the pieces of data in each section to see if that is the actual percent in there. Let's do an example, or I'll let you practice in your textbook to explore normal distribution a little bit further. Okay, good luck.